video on properties of log functions. So this is how things that you need to do to work with logs. And so this will be really important for solving. So we're going to make sure that we know all of these properties really well. So you're going to fill some of these in, and then we're also going to write words for how we know how to do these properties, because it's really better to learn these with words than to learn the symbols. So remember that we talked about that logs are actually exponents. So they are the exponent to which the base b must be raised to give you what's inside. Well, because they're exponents, they kind of work like exponents. So we have log base b of mn. Well, if you're multiplying and you have exponents, remember that you add the individual exponents. So that's basically the idea. And so the same thing will be true for subtraction. So what I want to write is how we would learn these rules for the product and quotient rule with words. That would be better. So the product rule is the log of a product equals the sum of the logs. So look carefully at it. The log of the product equals the sum of the two different logs. So much easier to learn this with words than it is to do with formulas. So the quotient rule would be the log of a quotient equals the difference of the logs. So again, log of a quotient, so we're dividing, equals the difference, which means subtraction, of the logs. And then the power rule, we just take the power and it gets multiplied in front. So there's not really words for that. Just remember, you can take a power when it's inside and multiply it in front. So these are all things that you would have had in Algebra 2, but we're going to go ahead and do some review with it. And so we'll talk about how to do all those things. So we want to expand the logs using the properties. And so there's a lot of reasons in other math classes later for sure that we need to be able to expand these things. It helps us with some of the things that we do in calculus, especially to make it easier on us. So we have a product. So we know that the log of a product equals the sum of the logs. So we keep the base that we have, which is 10, because there's not a base written, and we just split, and they're all plus. It's the log of each one of them. Then we look to see if there's anything else we can do. Well, log 8 is log 8. There's nothing we can do. Log x is log x. But then on the last one, we do have a property that we can pull the power and put it in front. So we'll have 4 log y. Now, we could do something with log 8, possibly, and so sometimes when you're trying to simplify, you may have difficulty. This answer is fine, but sometimes you're doing a problem and you wrote log 8, and then you go look at the key, and the key does not have that. So here is sometimes what happens. We can write 8 as log base 10 of 2 to the third. Remember that exponents are what we deal with logs a lot. And then because that's now an exponent inside, we can pull the exponent in front. So you might even try sometime and do log 8 on your calculator and hit enter and see if it changes it to 3 log 2, because it probably will. But this answer that I boxed in is perfectly fine also. Just sometimes when you're matching, you might want to watch for that. All right, so let's look at B. So B is definitely a quotient. So I'm going to follow the rule for quotients. So I'm going to take the log, or the ln of a quotient, equals the ln of the difference of the logs, so the difference of the ln's. So I take and I split it, but each of them is now an ln. So it's the log of a quotient is the difference of the logs. Now, again, exponents are really important. So I'm going to rewrite x squared plus 5 to the 1/2 for the square root. And then I just have minus my ln of x. Now that I made it a power, I can move the power in front. And so this would be normally the way we would see that written. And so that's, again, if you see square roots or you see something that can be written as a power, it will write it as a power on the inside, and then we can pull the power in front. All right, so now we're going to go the opposite way. We're going to condense this down until it's a single log expression, which is very, very often what we do. So some students might look at this and say we're immediately going to have the difference of the logs, but we don't because we have this 2 here. So until we have ln of something minus ln of something, we're not finished. So we're going to go ahead and leave this one alone. And on the second one, we're going to put the power back up. Now be careful that that ln, it's x, y, both x and y raised to the second. Then now I have the difference of logs. So now I can make the difference of logs equal to the log of the quotient. Now again, we might feel like we're finished here, but we could simplify it a little bit. The bottom, when you are multiplying and you raise to a power, each thing gets raised to the power. So we can do both of those, and then we can simplify x to the 5th over x squared is x cubed. So we have x cubed over y squared, and then it's ln of all that. So there's another example. All right, so let's do condensing with log 5 minus log x. So this is the same base. So we have the difference of the logs. So we do the log of the quotient, and that's it, and we're done. Now on this C, we can again see that we have a sum, but we can't use that property yet until there's not those numbers out in front. So we do have to be careful here. If the 3, the power of 3 gets put back up there, it's the whole inside of the ln that gets raised to that power. And same thing here. When you put the 2 back up, you have to put the whole thing raised to that power. Then, before I even do any more simplifying, I'm just going to go ahead and raise everything inside to the 3rd, so that does make it a little bit easier to write. So that's going to be, remember, when you raise a power to a power, you multiply the power. So that's x to the 9th, y to the 3rd inside this one, and then you'll have y squared, and then z squared squared would be z to the 4th. Then now I have the sum of the logs equals the log of the product. And then I have one more thing that I can do to simplify, which is those y's can get put together. So when you're multiplying with things with exponent, we know we add the exponents. So there's my final answer, all put together as one single log. All right, so the next thing on here has to do with the change of base formula. And I'm actually going to skip that because we don't need that anymore. That's an old-fashioned thing, but our calculator does the base that we need. And when we need something similar to this, we'll bring it up. So we don't need to do that. If you want to do all of these in the calculator, you just push the log button, put in the power, or put in the base that you want. Okay, so let's talk about log functions that are not base E and all of the things that we know about them, and then we're going to sketch it. So let's go over here and talk about things like domain and range. Well, again, we've talked about domain all year. There are 3 times that we worry about the domain where it's not going to be minus infinity to infinity. The 3 main things: if I have a denominator, I can't divide by 0, no negatives under square roots, and no 0 or negative for logs. Therefore, the domain 0 to infinity. Then remember, the range is the same as the domain of its inverse. Well, exponentials cover minus infinity to infinity for their domains. Therefore, the range of its inverse is going to be minus infinity to infinity. We know that it's continuous. We know it increases everywhere on its domain. It doesn't have any symmetry. It's neither even or odd. It is bounded neither place because it goes 0 to infinity not on the domain, but the range is minus infinity to infinity, so it's unbounded. There can't be any extrema because remember it's increasing everywhere, so it would have to change from increasing to decreasing or vice versa. Horizontal asymptote, it has none. And vertical asymptote, same as ln, it's x equals 0. This is very much the same graph, just different numbers. The end behavior is going to be as I go to infinity of log base b of x. I'm going to go to infinity. It increases. Just remember, it does it super slow. And as I go to minus infinity, actually doesn't make sense. I have to approach 0 from the right because there isn't anything, remember, on the other side. We'll see that on the graph. So as I approach 0 of log base b of x, I know that I get minus infinity. And we'll go back and look at the graph on how we do that. So it's very much just like ln of x. We have an asymptote here. It's going to cross at 0, 1. And it's going to go down toward this asymptote, and it's going to increase slowly. Now, it's going to increase a little faster depending on what the base is, but since I have generic base of b, it's going to look just like this. It's just going to be, it's just an increasing function. That's for the base being greater than 1. Remember that the base can't be 1, but if the base is between 0 and 1, that will change things a little bit, okay? So let's talk about what that looks like then. So if we have a graph and we want to change it to this graph, we're actually not going to, we're not going to talk about this because we're not going to talk about the transformations. So let's just say we want to graph log base 5 of x. So forget doing it by transformations. Well, we know that the log is going to have a vertical asymptote. We know that it's going to cross at 0, 1. And then we know that it's going to have the point, 5, 1. Because an exponential would have the point 1, 5. And so here's going to be the graph, log base 5 of x. So that's how easy that is. So we're not going to, again, we can talk about this one, but here's how we're going to graph it, not by transformations. So what we're going to do is think, okay, so let's take the inverse of this function. So the inverse is y equals 1/2 to the x. So we can make an xy chart for that, and then log base 1/2 of x would just have all the x's and y switched. So let's just put a couple of points in. So let's put in -1, 0, and 1. So if we plug in -1, we're going to have 1/2 to the -1. Well, raising to the -1 means flip over what's inside and raise it to the first. So that gives me 2. If I put in 0, 1/2 to the 0 is 1. Anything raised to the 0 except 0 to the 0, anything else raised to the 0 is 1. So that's always going to be the case. And you're always going to have the point 1 and then the base, 1/2. So to graph log of 1/2 x, I simply switch all of these points. So I'm going to put a couple of points here. So instead of -1, 2, I will have the point 2, -1. And instead of 0, 1, I'll have the point 1, 0. And instead of 1, 1/2, I'll have 1/2, 1. So you can see if b is less than 1, it is now a decreasing function, which should make sense because you remember this function would be exponential decay. And so its equivalent or its log function that it is the inverse of will also be decreasing. All right, so if we want to do an application problem, okay, so like the next problem, you're going to simply put all of this in the calculator. So I'm going to do that with you so that you have that to do. We've now done this quite a few times though, so I think you should be getting pretty good at it. You see a table, you're going to do a listen spreadsheet, and you're going to make a scatter plot, and then you're going to fit a function. Well, this time you're going to fit a log function to this graph. So we're going to type, and remember we type something. Well, this is called price, so I'm just going to type price, and then arrow over to that, and it's quantity or it's demand, so we'll just put demand. It's up to you. You just have to put some word. I don't know why that doesn't want to work, so you just put something that represents that column, so that's demand. So now I'm just going to type everything in. So I have 2400, then I have 2100, then I have 1800, and so on. So you go ahead, get your calculator out, you can hit pause on the video, and you can type everything in. You really should practice this because this is a big feature that we use a lot on our calculator. So we go to the next column, and we're going to put the demand numbers in. So this is the price of computers, and then the demand that you will have for that price of computer. So again, this is just the table that you have right there in your notes. Type all of this in, and there you have it. Then remember, so again, hit pause if you're still entering, and then start it again. So we're going to add a data and statistics page, and then we click on the bottom to add a variable. If we look, we have price as the X, so we're going to put price here, and then we click here for the Y, which is the demand, and here we have a function. So what we're going to do is we're going to, again, fit a logarithmic function to this data. So we do menu, analyze, regression, but now we show logarithmic, which is number 9. So here is the function that we get. So this is the function that represents our data. And then it says, use the function to find the number of personal computers that would be in demand if the price was $1,500. Well, remember, price was saved as X. There are several ways that we can do this. So let's write it down, and then we'll go back to the calculator. So remember, we can store this function. So this is what we got. When we did our regression, so this is the logarithmic function. Then we want to figure out what happens when we have 1500, which is essentially we want to solve y of 1500. Well, this doesn't need the solver or anything like that, so you can just type this one into the calculator. It's not that difficult. You're just going to fill in 1500 in place of ln. So I'm going to encourage you to do that. Just do this on a calculator page. See what you get, and you should get that the answer is about 176 computers. And so this is just a different type of regression. We've done a lot of different regressions so far this year, and this is just showing you that there's a different kind that we can use using logs. So that's it. It's a deceivingly short video for such an important bit of information. Make sure that you practice those properties over and over and over again. It's really, really important that you're able to do change logs around and use the properties. That's a real important feature. So that's the end of this video.